If, Elif, else blocks are used to execute code conditionally on the value of a logical operation. Conditional blocks always start with an if. The elif is optional and allows multiple conditions to be separately tested. The else is also optional and is run if the if and any included elif clauses are not hit. If and elif conditions must be scalars, Boolean arrays are not accepted. If blocks use whitespace to demarcate the start and end of the code covered by the if, elif, or else statements, and so consistent indentation is essential. Start by opening Lesson 17. The first problem asks us to simulate a standard normal using np.random.standardNormal. We start by importing NumPy. We can assign value to the output of np.random.standardNormal. If is the basic conditional statement. An if block begins with the keyword if, followed by a logical condition that should evaluate to either true or false, and then a colon. All code that is executed when the logical condition is true is indented relative to the if statement. The best practice is to use 4 spaces. An if statement is used to check whether the value is less than 0. We end the statement with a colon. The only code in the scope of the if statement is a print command that shows the value. Running the cell prints the value if negative. We can run the cell multiple times, and it will sometimes print and other times do nothing. Next, we generate another standard normal. If-else blocks ensure that one, and only one, of the paths is always visited. If the condition in the if branch is satisfied, then the code after the if statement is executed. When this condition is false, then the code in the else block is executed. If and else must have the same level of indentation, and code in each block must be consistently indented. Dedented code signals that the if-else block has completed. We can use an if-else block to print the sign. The if clause comparing the value to 0 is used to see if the value is positive. The code block prints positive. We then dedent and enter else followed by a colon. Finally, the else block prints negative. Running the cell will print positive or negative. We can run it multiple times to get different outputs. The final task asks us to classify the output of a t-random variable as a negative outlier if less than -2, a positive outlier if larger than 2, and an inlier otherwise. We can generate a student's t with 2 degrees of freedom random variable using np.random.standardT with the argument 2. Elif extends if-else to multiple conditions. In an if-elif-else block, exactly one path is visited. The else is optional, and so an if-elif block may not execute any code. There is no limit to the number of elif conditions. We always start branching logic with an if followed by a logical value. I have decided to test if it is less than -2 first. If the value is very negative, then print negative outlier. We then dedent and enter elif value greater than 2 followed by a colon. The only code in the elif statement is a print command that shows positive outlier if this command is run. Finally, we can dedent again and enter else followed by a colon. The else block runs if neither the if nor the elif condition is hit. Here, we print inlier. We can run the cell to get a classification. Running the cell multiple times shows that we hit all three paths eventually. I added a print statement to show the value, which lets us check that we are printing the correct text. If, elif, else statements allow for code to be executed conditionally on a logical value. The if is always required in the first statement. The elif and else are optional. Else should be the final statement in a conditional block. Remember that Python is whitespace sensitive, and so consistent indentation is required when writing if, elif, else blocks.